Alcohols are a family of compounds that contain an OH or hydroxyl group. This homologous series is very important in our lives, and alcohols have many purposes ranging from fuel all the way to chemical feedstock. Ethanol is probably the most famous of the homologous series, as it is the alcohol contained in alcoholic beverages. It's also a really good showcase of all the physical properties of the family. Now, the physical properties of alcohols are pretty interesting. Alcohols compared to alkanes are less volatile, have higher boiling points, and they're more soluble. But before we dive into that, let's talk about the how. As mentioned earlier, alcohols have a hydroxyl group. Now, if you remember, hydroxyl components are part of a few special groups that can form something called a hydrogen bond. Both alkanes and alcohols have intermolecular forces in the form of London forces, but since alcohols also have hydrogen bonds between molecules, a lot more energy is required to overcome the intermolecular bonds in alcohols. Hence, they have a higher melting point and lower volatility, meaning they don't evaporate as easily as alkanes of the same chain length. Furthermore, alcohols like methanol can form hydrogen bonds with water, meaning that they're much more soluble than alkanes of the same chain length. One important thing about this relationship though, it's not easy to spot unless you look closely at the boiling point of each homologous series. As you can see from tables, the same chain length of carbon chain have vastly different. Let's talk about the reactions that alcohols undergo. I will discuss 3 of the 4 today, as oxidation of alcohols will be covered in a separate video. The first reaction I want to talk about is combustion of alcohols. Alcohols such as methanol undergo combustion reactions with oxygen, forming compounds carbon dioxide and water. One important thing to note for combustion reactions with alcohol is that they utilize fewer moles of oxygen when they react than alkanes use for the same chain length. It's also notable that they release a lot of energy in this process, hence alcohols are good fuels. The second reaction I want to talk about today is the dehydration or elimination reaction of alcohol. It occurs when an alcohol is heated under reflux with an acid catalyst. This could be either concentrated sulfuric or phosphoric acid. In this reaction, a water molecule is removed from the original alcohol, forming an alkene and water. The last reaction we will cover today is the substitution reaction of alcohols with hydrogen halides. This is a two-step process, and the entire reaction occurs under reflux with the presence of concentrated sulfuric acid. In the first step, potassium bromide reacts with sulfuric acid to form hydrogen bromide, which then proceeds to react with our alcohol, ethanol in this case, in the second step, to form a bromoalkane and water.